Matt, all yours. Thank you.
Hello, everyone. Welcome to Funding Circle. Thank you for the introduction. I'm Matt. I collect titles rather than remove them, which is why it's so long. Anyway, I'm here to talk about a journey we went through at Funding Circle. We are massive users of Kafka. We try and use it everywhere. A journey we went through, which started, and most of what I'll talk about here was done about 3 years ago, 4 years ago, actually longer than that, 5 years ago, some of it. We're very early adopters of Kafka. So this is Kafka Streams, some of this work, 0.10. So some of what I'll present, hopefully some of you will think, but why the hell didn't you just use this other thing? And it's because it wasn't there. We used a lot of features from Kafka literally as they came out. Anyway, we learned some things as we went. I'll touch quickly on, before I get into this, what Funding Circle actually does for people who are not familiar. The high level, we lend money to small businesses, which is great. It helps small business owners in the UK and the US grow their businesses. Very good for the economy. But we don't lend our own money. So we have investors that provide liquidity and we match them together. We do all the credit scoring of the borrower. But off the back of that, we have a loan that a borrower has, they repay, and that money needs to go back to the people that invested in it, that we allocated. And what I'm going to talk about here is a system we used to replace an existing one that did that function, the distribution of money. So we're not talking about logging. We're not talking about operations that are relatively transient in the scheme of things. Some of, well, lots of the positions this system had to manage, and it's going to be fully Kafka based, had a 5-year lifespan. So the history, the sort of data needs to persist and needs to carry on being managed. A lot of money moved through the system. And obviously it's a financial system, so it's very important it's correct as well as performant. Like, you can't make mistakes with this stuff. And I'm going to look at or talk through a pattern we developed and that's kind of story and journey we went through to get there, which is hopefully interesting. So the existing system that we were replacing was a Restful microservices system, hopefully very familiar sort of pattern. It had grown up, it was a startup in the startup years. It did its job very well. There's a set of systems all with their own data stores. They all talk to each other over REST. There's lots of UIs, and this was great. But for the finance side, some problems did start to creep in. So especially when anything went wrong, there were manual corrections happening in databases. It's just very easy as an engineer on support. You just go on the database, you run an update, everything's fixed. That, though, would lead, if they were fixed locally, to hopefully I don't need to preach to the choir too much on this, but you get consistency issues between all those systems. The reporting, which obviously is highly important for finance, that you need to reconcile your accounts, you need regulatory reasons, you need to produce reports. They were all snapshotted into the warehouses and lakes. They would get consistency issues. And as we were scaling up, it was both becoming slow, unreliable, inconsistent. Why things were a certain way was difficult to reason about because people like me had just been in the database and fixed it. And when dealing with money, all these things are bad. The regulators don't like it. We don't like it. The accountants don't like it. And most importantly, the customers aren't going to like it. So we decided to replace it with a lovely event-driven, event-sourced system. Not just event-driven, but event-sourced. So all those events are durable, they're persistent. We chose Apache Kafka, and I think when the whole program was incepted, it was around version 0.6, 0.7. But because Kafka has a lot of the built-in resiliency, ordering, durability properties that you need in a system like this, so it's not an event bus, it's a distributed kind of journal database product. So you can be event-driven with it, but it also gives you the event sourcing approach. It would allow analytics to be driven off the same real-time operations that the system was. Lots of good properties, but we were new to it. It's a new technology and didn't really know what this was going to look like as we start to building things. I think, and the last point there quickly is also for accounting. Accountants don't use erasers, as the saying goes. It's immutable. So we can't just go messing around with the books and records anymore. That in finance is a very important property, which is now kind of enforced by the technology choice we've made. So we went through, and what I'm going to focus on here is one part of the system, which was investor state management, and that part of the system owned as we went through our sort of just DDD and event storming exercises, this state owns the investment in loans or a loan by an investor, what their position is, what money needs to be distributed to them as the borrowers repay. So it's managing both the flow of money and the investor's position. So all the reporting we send back to the investors were driven from this state. That is critical. Some of those investors are institutions and are under their own regulation. So we have to make sure these numbers are both timely and correct. Also, we're not going to big bang the whole thing. The first picture I showed, there's no way you're just going to move to that in one go. So this component was, I think, the second one that went live. But it's, and I think he's here somewhere, Will, who was the tech lead for it, described it needs to be like pulling the tablecloth out from under the crockery when it goes live. So we were going to replace some parts of the system. We sourced a bunch of events into Kafka to begin with to try and match the sort of design that we had. And then we can start building the new component using Kafka Streams off the back of that. It would shadow the existing system, and its aim is obviously to try and match what the existing will do a better job than the current system, and then we can turn it live. So our first attempt, we all got very excited. There's Kafka Streams sort of just come out. There's some DSL. You look at how this stuff works, read a few articles on it. It's effectively a reduced problem. So there's a load of events come in. You create the state as transactions go through. It's simple maths, add and take away totals of money, generate events out the other side. Surely we can write this by just consuming the topics and running a reduce function over it. This would output a new version of investor state. We produced a changelog of the same state out of the current system. And when they match, happy days, you switch over. So it sounds good. We had a go at this. Off we went. Obviously, there were some problems. We're not going to even try and build that component in one go, so it's an iterative process. The first few goes fine, but obviously every time we change the logic to deal with a new event, as you build up state and all the rest of it, you have to reset the topology because it's running from first principles. It's trying to reassemble the state from all the events in the system back to what it looks like. Every time you rerun that, you have to reset the topology, run it again. And remember, we're sort of on version 1 of Kafka about this point. The consumer does different things. If it's consuming the events live, if you reset it back to the beginning, the consumer will decide to consume partitions that in order, but probably in a different order each time you reset it. It will often consume all of one partition before it even bothers looking at another one. Then this was causing headaches because every time we increased the logic, the component ran and reset it, it would do all these strange, odd things. We could work around them, but the team was getting fed up with dealing with the consumer group offsets and having to go in there and try and fiddle around with them, run things in certain orders, start and stop it. It's a pain. It started to slow us down. So we needed something else in the system. So we came up with a term we refer to as muxing. So we split the topology into two. So at the front of it, if you like, we had a muxer, and its job was quite simple. It simply looks at all the inputs, does joins when we need to do joins, merges it all into a single topic. And that topic's important property was that each message on that topic drives one business action. The action doesn't need more than one message at all. It consumes one thing, which is why the joins are up the front there. And every message just causes one thing to happen. That let us deal with the ordering problem now up front. And once we generated that internal topology, the actual manager managing the state can just be run over and over again. You always get the same order back again now. That worked really well. We go back and forth. We still had to mess around a bit with the muxer. We added and sourced a new event in the system. You might have to replay that. But once you generated that internal state, the rerunning of the manager topology was very reliable. And this was like helped us accelerate. We started going fast again, which was good. The muxer ended up looking a bit like this. I think that is its final state. It's not too many input topics, but you see it was using the DSL to do a fairly straightforward set of streams operations. There are still some problems with this though. And as we went through more and more of the events, the bootstrapping of the system became more of a problem. It was still attempting to generate the investor state from first principles of all the events. That to begin with was fine. We could source all the creation events, that was okay. Most of the payments that have been made historically, that was fine, but edge cases around recovery or late payments, we started to run out of data in the current system. It'd been there since inception of the business. So the kind of first year of the business was a bit gappy. There were some events we just simply couldn't source at all. And the further we went back, we'd lose fidelity, if you like, on some of the events. There'd be fields that were missing information that we wanted as we were managing the state that existed in kind of the current previous month wouldn't exist 5 years ago. So we abandoned the idea of recreating the state completely from first principles and decided we needed to bootstrap it off of the current state of the existing system and then run the events after that point over it and see if it can do that operation. It's safe to go forwards, happy days. Injecting the starting state, though, into a DSL generate topology, especially back in the earlier days of Kafka Streams, is quite difficult because though it is in there, in the reduction, there's a sort of table, there's a RocksDB, there's a topic that backs that. Actually injecting your own state in that to get it going in the right format that's going to allow the reduction to run was a fiddle. Not that it wasn't possible, but we're a startup. We're trying to re-platform this, trying to go quickly. It's drag. We need to move out of the way of it. So we switched the manager bit to use the processor API. We sort of stopped using the DSL, which is still Kafka Streams, but effectively leaves all of the internal workings to your, up to you. We changed the internal state that the topology was managing to match exactly the external state that it's producing. So we have this kind of multi-directional property. And the manager component had a bootstrap mode added to it, where if you reset it, it would ignore all the events, but it would consume the state of the existing system, prime its internal state store to match that, and then you flip it back the other way and it will start ignoring that state, consuming events, and off it goes. This started to work really well. It allowed us, especially for testing, you could bootstrap base, back in time, various sort of versions of what things look like and run different types of events through it, which was very good. The use of the processor API also avoided one of the other problems. The DSL topology to manage all the business logic was quite complex. And certainly back then, and indeed is not the default today, if you forget to give every DSL operation a name, then Kafka will name the internal topics for you numerically. And if you change your topology, they will get a different name. And we certainly learned that the hard way a few times at Funding Circle. You make a little DSL topology change and suddenly all your internal state evaporates, and somebody's asking, why have you got so many partitions in production? Because there's hundreds of different versions of them from over time. Those problems all disappear with the processor API. Obviously, the problem you gain is that you need to write yourself a lot of logic that is provided by the DSL, but the trade-off was a valuable one for us. So in a bit more detail, what did the manager look like? It obviously consumed things. This was before exactly once as well. So we had a deduper in the front of it that would just record the UID off every message it had seen. And if it saw a duplicate, it would just drop it. And that was actually quite useful for replaying as well. You could mess around with what was in that or whether the mucks are assigned new UIDs to messages or not, about whether you wanted this topology to do anything with them. And then it would look at the event it had, and it would effectively dispatch it to a handler, which would do everything. It would get given the current state, the event, and its output, it was a pure function. All of those handlers would just say, well, here are the resulting events, and here's a new state, and the little framework we had that sat around it did all the work for you. This made the business logic much easier to follow as well. So it helped speed up engineering, because in the DSL world, your kind of business logic is spread out over a whole set of streams operations. And your kind of top level view, if you like, is very generic. Filter this, map, reduce, aggregate. It's not immediately obvious what it's doing. In this world, it's kind of inverted. Those operations still exist, but they're wrapped inside a business container that says, like distribute repayment, distribute recovery, reverse repayment, whatever it is, you know, as an engineer straight away what to look at. And it's very easy to neatly compartmentalize them in. This was all written in Clojure, namespaces, but classes, you know, whatever language you're using. So that was what the topology ended up looking like, which has this lovely property that basically all your hard work sat inside there. It follows the kind of hexagonal architecture pattern, is put Kafka on the edge of things. You still use it. You're still in its runtime. You still have all of its reliability, transactional guarantees. But from a sort of engineering point of view, you can write your logic. The maintainability, the testability, especially of what those functions did, was greatly reduced. You don't have to use Kafka at all. You can cover a lot of unit tests before you even get to trying to run them. It was a very good outcome, and following this pattern allowed us to complete all of the work. It was a definite accelerator. I think once we homed in on this, we finished within about 6 weeks, all the work that was left. We had one problem though left, which was the immutability of Kafka. So however many safeguards we built into the platform, it's still going to go wrong. Even if it's 100% safe when you go live, the next time I touch it or someone else does, we might break it. We could incorrectly ignore events, and in those situations, you can't always republish them because they are data on the outside topics. The event coming into this system was also being consumed by several other systems. So it's not always an option for the upstream publisher to republish it because everyone else needs to know to ignore it themselves, whereas you actually want to process it again. Plus, that information will go into our analytics, into our data lake, and cause a duplicate there. Sometimes it would just go wrong and you get bad state, and then what do you do? Because it's handled the event, but it just didn't do the right thing. That led to a slight paranoia about anything unusual. You get the poison pill problem where, like following the DevOps principle, you either work or you just crash spectacularly. And so we would crash spectacularly, but then the whole thing stuck. And this system's attempting to distribute thousands of payments, doesn't have long to do it. It generated millions of distributions off the back of it. If it gets stuck for one investor, you're affecting everyone else, which is not a good customer outcome. So the final thing we did, we looked at the sort of following the finance principles. How can we reverse and restate things? How could we reflow an event through the system just for this component? And also, let's just accept that sometimes we're going to have to correct state. We implemented those in Kafka, which had the great property that it's auditable. You always know you've done it because it's not an ephemeral fix done in place, a mutation. It's a deliberate statement of intent to fix something with a result off the back of it, or to replace something with a result off the back of it. So we end up with this. We added the yellow bits, the dead letter queue. If the processor didn't like anything, it would reject it. There were still a few cases where it would crash in more serious issues, but it would reject events it didn't like the look of. It would mark the state as being potentially out of sync now. So any further events for that particular piece of state, and there were thousands being managed in there, would also get rejected. Now, the nice thing about Kafka is that the order of rejection is preserved. And once we'd addressed whatever the issue was, you could just spool the rejects back into a private replay topic, and they'd go all the way back through the topology and be successfully handled this time. So we used that a few times if there was a code fix problem. We also added the blue one, a data fix topic. Now it's carried a very specific event that carried the UID of the state to fix, the field name to fix, and then its current value and the new value. And it would run a compare and set on the state. If it didn't like anything, it would spit out, sorry, that didn't work. It had a test mode as well, where it would go through and the result would be whether it would work or not, or you could run it for reals, and it would put out in the data fix topic that it had applied the data fix, and it would publish the new state as a result of that. And we could also use this topic with like a no-op operation just to force the republication of state if somebody downstream, for whatever reason, hadn't consumed that. And this was great because now we've got a fully Kafka Streams based management of our financial instruments for our investors. We have all the benefits of Kafka, its reliability, the kind of ordering guarantees, the observability, auditability, which has helped us debug all sorts of sort of strange issues that happen. But we can also have a break glass for fixing stuff if it goes wrong, and for replaying privately in the component if that's required. And that pattern that we came up for that component, we've used multiple times now at Funding Circle. It's now does use exactly once. We could probably, I don't know whether we still need the deduping bit anymore. But this concept of how to bootstrap it up to the current state, the nice property of bootstrapping as well is it also allowed us to back up the topology, because if the bootstrap state and the state the system produces are the same, as long as you back up that state topic and the position of the consumer groups of the input, you can always recover the topology back to that state. And depending what happened, whether it's corruption, data loss, whatever, you can replay the system back from the point in time that you've captured, which is a very useful property and quite hard to do if you're not explicitly sharing the same state internally as externally. It gave us data fix. You can still kind of do your SQL update equivalent. Because it's all Kafka based as well, we never did, but you could have built a UI over that. You just sync them all into a database somewhere, let ProdOps teams see that a field's wrong, put a correction in, it fires the event through, and it still has all the audit properties. So it's a great pattern. The Muxa, we use the DSL still at the front. We tend to write the backend thing as processor APIs for the properties I described. But yeah, and this went live. That component I described there has probably been live for about 4 years now. The whole system that I described at the beginning, we did actually build the whole thing. So it's all Kafka based, all the financial events on it. And this is in the US Funding Circle system go through their fully event source. They're all sunk into a data lake. So we have the same real-time backbone data model in Kafka. Is driving both operational and analytical outcomes. So it allows our analytics to become real-time if we want to, and it allows our real-time data to be used analytically if we want to without having to do anything. It's proved highly resilient. We once, right in the middle, and actually I'll talk performance first, I haven't really touched on that, but the system this was replacing took 2 hours to run the investor distribution. When this first went live, I was asked by the CTO at the time, how fast was it, Matt? And it was 2 minutes it took to do the same job, which was quite impressive. And it gave us lots of headroom. It was resilient once inside that 2 minutes. Very unfortunately, about 30 seconds into it, AWS had a network disintegration in the US East 1, and the whole cluster fell apart. We were managing our own Kafka at this point. So all the brokers fell apart, all the consumer groups disintegrated everything. Now, in the previous system, this was like a nightmare scenario because we had someone had released money, they'd done all their work. The component managing loan state had done about half of it. Our investor component I described in about a quarter, and the ledger sat behind it, had done about 10%. They're all out of sync. In the previous system, when you brought the system back up, it would just be stuck, and we'd be there like for days, probably trying to figure out what was missing, what was where. The Kafka-based solution, literally as the network came back and we started everything up, you didn't have to do anything. It just was eventually consistent. Everything caught up and knew exactly where it was. And I think within 30 minutes of the network being recovered, all the books and records were reconciled with like hands-free mark, which is testament to the reliability of Kafka, really. It's, as I said, it's proven to be highly observable. We've, I think, shown, because there's often a fear from engineers who haven't worked with Kafka, but how do I fix stuff with immutable data sets? You can do it, and actually you get the best of both worlds, because not only can you fix stuff, but you don't have to hunt through Jira with a UUID to see why something looks odd. Yeah, you just look in Kafka and there it is. You go look in your data lake, there it is. Combined with this sort of entry level of, say, use cases of Kafka, people use it for log and telemetry and system events. You can combine that with your business events. And ironically, actually, it's something that Funding Circle we haven't done yet. We use Kafka for like the core business reasons. We use it in the UK for all our loan originations and credit scoring. We use it in the US for all the money movement. We don't use it for system logging, but if you did, you can start to join a much bigger picture of cause and effect on like the impact of outages, all the rest of it is a force multiplier, I think, there. And as I said, the system went live and is live. And when that's me. So here's a story of a journey through the earlier days of Kafka and some of our learnings and patterns from it. Thank you for listening. Any questions? Yes. Yeah, so the first one was serialization. We tried a few. We used prismatic schema for a while, but we'd settle on Avro. So all of this was built with Avro. The internal topic described in the, oops, lost it now. It's gone round. There you go. The internal topic of consolidated events, though, was just JSON. But all the public topics at Funding Circle are Avro schema based, which has its pros and cons. It can be a fiddle sometimes as an engineer in the kind of real-time world, but there's a lot of advantage, especially when we start syncing into databases and the data lake around backwards compatibility. And I think your second question was on features I wish I'd had, or we wish we'd had 5 years ago. So exactly once is definitely one that came out towards the end. One of the things we had to build custom to begin with was there was no concept of like global state stores when this was started. So that's definitely something we used as soon as it came out. It didn't work properly when it first came out, but it did fortunately just in time start working properly by the time we went live. The naming, and I think that is all golden now, but the naming of internal topics used inside a DSL-based topology, and I would love as a feature at some point to deprecate the ability not to give operations a name, which would be, I think would be very useful. Even when we finished, this went live, there are a few operations that you still couldn't name the internal topics for, and we actually had a fork of Kafka at one point to deal with that problem. I think there's still work being done. I think something Confluent are looking at the backup and recovery. It's the main thing used to keep me up at night, is like losing all the data is one thing. We can usually put it back from our lake, but if it gets corrupted, it's more of a problem in the system if you want to actually remove data from the system. That I think there are solutions for now that we are using. I mean, it's hard to pinpoint something with the DSL itself. There's lots of types of joins and the rest of it that get added over time. I think it would be good, like looking forwards, to see a more promotion of the processor API itself, because I think it is very powerful and I think sometimes overlooked by especially newer people to Kafka. But that helps a bit. Yes. Yes. So, yeah, sure. So we had still have a job that effectively brings the process down, quiesces it, waits, looks at its internal state, make sure it's stopped doing anything, then it snaps the consumer group offset and snaps all of the state, which fortunately in Kafka is really fast. Even with the ledger had millions and millions of events and it would all go into our lake very quickly. And then once that's finished, it would just bring the process back up again. And it actually is the eventual consistency approach used here as well did mean that that process, just like releases, just like a lot of operations, meant you were very free to just fiddle around with topology settings, deploy stuff, even in the middle of stuff happening, because you knew the system would always recover itself. And it's certainly, as an engineer, something I always try and do and encourage, that you actually shouldn't avoid, but you should want to deploy your system in the middle of it doing things, because that's when you learn whether it's actually resilient or not. And if you can do that, if you're fearless enough and you can do that, you know that when bad things happen, you can do the same thing, and it actually has the right properties to catch up. Nothing bad happens. Yeah. So yeah. Cool. Any other questions? Yes. Yeah. So how big is the instance is the question. So we ran 5 brokers for this. Now, one of the things about Funding Circle is certainly on, at least here on this end, Funding Circle's issue is a data complexity problem. And it's because we deal with small businesses. We're never going to have millions of customers an hour turning up because there just aren't that many small businesses. But in originating data, the amount of data we need to have to like lend someone money is very high. And actually this model was based on, sadly, a part of our business that doesn't exist anymore, but we used to have retail investments. People like you and I can invest in loans as well. And the average number of investors per loan in that model was 1,000. Well, actually, maybe it was just over 1,000. So one payment in could generate, and when you look at the accounting, each of those 1,000 was actually 9 accounting events off the back of it. So it multiplies quite quickly into the millions. But our real challenge wasn't so much, I mean, we had a few topics with millions of messages, but throughput was never anywhere really near the edge. And we were fortunate that we basically ran the safest settings Kafka has for everything. We could still get like 1,000 to 2,000 like transactions, not messages, but transactions a second to go through it. It was a number of topics. This had, I mean, it was about 140 topics. So the complexity of keeping track of all that and all the schemas. We had several versions of those topics. We had to make lots of non-backwards compatible schema changes as we went. And these were the days before multi-schema topics. So we'd end up with lots of versions of topics and sort of tune those back up again. But yeah, in production, we've always run 5 brokers, and test environments have 3. Yeah. Well, consumers, there were, I remember because we did a migration, but probably in the end, there's around, I think it was 60 to 70 consumer groups. The actual core streams processor, there was maybe 7 key ones, but they would each deploy multiple topologies. And you've got a whole world of Kafka Connect around the edge as well. The UI, there was a single UI, is one of the good things about this. It could just slurp all the events up, and it had 100+ topics all going into it, into a database, and it had its own publisher. Yeah, that was actually another feature. I'm just remembering it now. One of the features I wish we'd had at the beginning was, nowadays in Kafka, once you have a consumer group and it's running, it's not going to lose its offsets. But when this went live, it would only keep its offsets if something had happened, because it only wrote the offset when it committed something. And if nothing happened on a partition for 2 weeks, the retention time on the backing topic for the consumer groups would delete it, and everything was fine until you deployed it, and some of your partitions would go back to the beginning of time and deploy anything, which is another reason we run dedupe stores. Sometimes we had, again, some harsh learnings from that. And then the follow-up learning of how to correct that when you've done everything twice by accident. So, yes.
Kafka beginner here. What's the definition of DSL-based topology? Is it the combination of public partition plus a specific chain of map filter things that you do in the code?
So that's a good question. So the DSL is a specific. So Kafka Streams is built on top of what they call the process API, is what's used here, which allows, effectively what it does is it allows you to run a consumer group and producers like kind of transactionally safely with each other. So it manages the commit of the consumer group's offsets based on having published something. And with the transaction with the exactly once model, it manages that transaction messages need to go on the topics around that. But the only thing it lets you do is process the message, and then you generate output and you sort of manually output it. The DSL is the kind of domain specific language they provided on top of that, which is the KStream, KTable, global KTable. Yeah, so the KStream, KTable, global, those classes are the DSL. And what they do is they implement a very common set of operations we tend to use in these things that are implemented for you. So you don't have to figure out how to do a join in Kafka yourself. You don't have to figure out how to make a backing store in RocksDB safe and come back when you redeploy it. No, that's in Java. And what we did, we then built a Clojure layer on top of it. It's a whole separate talk. If people are interested in Clojure, I'm happy to talk about that afterwards and why it's a good fit. But yeah, no, the DSL is the Kafka Streams. When you Google it, usually what comes up is the DSL, and it's the process API it's described afterwards. Anything else? Or probably I'm being called for time. Quick, if it's quick. Yes, the state is a change log, so it's compacted, so it never forgets anything. So in Kafka, it's written multiple times. So we configure this, it would write 3 times. So there's 3 separate brokers persisting it independently. So the whole system does, we're also syncing that state into our data lake, and we can publish it out of our lake back into the topic if we needed to, which is how we basically just chuck the whole thing into S3 and you can put it back again. Cool. Right, I'm sure hand over to the next gentleman now. Thank you very much for listening. Anyway.